At the time I sold Xenon to GE, there were two types of membranes, hollow fiber membranes and flat sheet. And both of these have been improved to the point that they were practical and used, but I didn't see tremendous opportunities to lower the cost to the point where it could be affordable and reliable to the level that it had to be to supply the world. The idea of Fibracast was basically changing the architecture. So I used to compare membranes to computer chips. When you have computer chips, you basically try to keep making that particular chip better and better. And when you can no longer make it better, you invent a new architecture. Fibracast was a new architecture. It was neither a hollow fiber nor a flat sheet. It was something in between that it appeared to me will solve the problems I knew the products had with reliability, and also it had the potential of great strides in terms of cost.
My name is Steve Watzik, and I'm the chairman and president of Fibracast. I'm here to talk to you today about an issue that's near and dear to all of us, and that's water. Fibracast started with a clean sheet of paper, looking at what was positive, what were the strengths and weaknesses of all of the existing MBR technologies, and how do we combine those, as well as put additional attributes so that we have an even better technology. FibrePlate's a hybrid of the existing hollow fiber and flat sheet configurations. This is becoming the membrane of the future for several reasons. We're able to create a truly horizontal membrane that allows us to open up the flow paths for much higher solids. It becomes much more hydraulically efficient, energy efficient. We can now use the flow of the wastewater that's normally used for the biological process to also help clean the membrane. And the packing density is much higher, so that we end up with a much smaller footprint.
Hello, my name is Chuck Bennett. I'm the Director of Systems Engineering at Fibracast. The biggest problem we've seen in the industry over the last few years is they still struggle with solids handlings, debris, and costs. The problem with the vertical orientation is the air is trying to come up in the water, and the water is coming through the membrane, and they're colliding into each other. It's creating turbulence, but they're not working together. As well, the solids are being lifted up through the membranes, and they're getting caught in these obstructions that are in the way. Here at Fibracast, we solve those. We've taken the advantages of a hollow fiber and a flat sheet, and we've changed the flow patterns to make that work. We have our membrane sheets in the center here, glued together, and we can now take all these modules and put them together in a cassette, so we can configure this to any size that you need. And we've done one other thing. Instead of having the water come into the side like we talked about before, we've arranged our system so the water comes up from the bottom. And this makes for a highly efficient tank and performance system. Well, our membranes are built with 3 layers of reinforcement. And because of the interior construction with the 3 layers that makes both a flat plate and a hollow fiber, these units will self-heal. And the entire module will continue to work. So once again, your plant continues to operate, the quality is protected of your effluent, and you're not shut down, which is the biggest concern for every wastewater operator.
Talking about the service, in most situations or most places, you normally have design, and then you go on to installation and commissioning, and that marks the end of the project. Well, that's not the case for us, but it's the service with the engineering and the product that makes us not only the membranes of the future, but the company of the future.
Fibracast is led by a team of industry pioneers with collectively hundreds of years of membrane bioreactor experience, and supported by a team of passionate, committed professionals that are 100% focused on MBRs. Our mission and passion is to raise the standards of MBR and provide the next generation to meet the existential challenges facing future generations.
So we started doing evaluations on several different types of membranes. We've had, several different styles. We had each manufacturer bring them in, laid them on the table, looked at them, compared them, tore them apart, squeezed them, cut them, ripped them, tore them. At the end of the day, we come across the hybrid flexible flat sheet membrane, and that was the membrane of choice. The other thing that we looked at is the manufacturer of this particular membrane had been in business for several years. Their expertise and their experiences have been long before this flexible sheet. I mean, they had developed a hollow fiber type of membrane. They knew the technology. They understood the programming, the PLC controls, and they were just trying to be a little bit, more on the front edge. They were just looking forward to advance the technology. With them being a smaller company, we would be more supported. With the changes in the technology, there's always the opportunity to look for what's new, what's the best, what have we learned, lessons learned. And again, that goes all back to, everybody has the same goal: affordability, maintaining the process, and longevity. We made the right decision.
We've been doing waste energy projects with Energia, and a natural generation of the next generation of membrane products was Fibracast. There was some considerations before my firm and myself were willing to use a new product. I actually went to Delphos, Ohio, talked to the operators, and then I talked to a number of process engineers who were doing similar due diligence. I became convinced that this is not only a good product, it's technology breakthrough for the membrane industry. With a smaller footprint, less power. We have been in business for 75 years and have a high degree of design build projects we've done, over 100, exceeding $1 billion just in the last 10 years. We always have a client first, project first mentality. And that culture perfectly aligns with our experience with Fibracast, in that it's what's best for the project, what's best for the client, and that's what we deliver.
I am the general manager for the Victor Valley Wastewater Reclamation Authority. And here at VVWRA today, we treat wastewater from 4 different communities. We're a joint powers authority between the town of Apple Valley, the city of Hesperia, the city of Victorville, and the county area. These member agencies supply us on average about 11 million gallons per day. And right now we're in the process of putting online 2 sub-regional facilities that are utilizing the Fibracast MBR systems. These facilities were put in place to help with some capacity concerns we had going forward. And we're excited today to partner with Fibracast and put these in use for our communities that we serve.
Fibracast was incredibly competitive in their pricing and for double the same throughput in the same footprint. Their team of engineers have been there, before the plants were built, during the construction of the plants, through the commissioning and the startup of the plants. They're always there to lean on with any questions.
I'm Andrew Henriquez. I'm the operations supervisor here at Victor Valley Wastewater. So as we were running Hesperia every single day, we were still trying to keep the biology alive there, obviously. Our mixed liquor concentration ended up reaching around 23,000 milligrams per liter, whereas typical MBR operation is 5,000 to 8,000 milligrams per liter. So it was just significantly higher than what it should have been. It's like trying to suck a smoothie through a coffee stirrer. It just doesn't really work very well. But those membranes were able to run really well through all of that.
My name is John Mura. I'm the General Manager and CEO of East Valley Water District in Highland, California. We are building what we believe to be the state-of-the-art Sterling Natural Resources Center, which is a recycled water facility that's taking 8 million gallons of sewer flow and turning it into 8 million gallons of recharge. Not only are we actually taking care of sewer treatment, but we're really trying to change the way people design, construct, and accept sewer treatment facilities in communities. So we are really trying to put this whole industry on its head. And when we decided, who are we going to partner with, it was obvious that we wanted to invest in emerging technology. And Fibracast was right there at the forefront of that. Understanding that their product will allow us a huge amount of flexibility in terms of footprint, because they really require so much less space, but also to invest in a company that is going to be with us for the long run and is willing to, break barriers, shift paradigms, and really invest in us as much as we want to invest in our community. Well, I mean, you have to be honest. You can't talk about membrane technology without talking about the Benedicts. Andrew and Diana have always been at the forefront of this, and obviously this is their second go around in this arena. They were wildly successful with their first product, and I think we all know the history of that product and kind of where it went and where it is today.
It was 25 years ago, trying to explain to people that they could save money by putting membranes directly in their bioreactor instead of after a clarifier. And no one believed me. They thought I was crazy. I was a woman and I was crazy. Today, membrane bioreactors are state-of-the-art technology. Immersed membranes are state-of-the-art. I'm very proud that we were visionaries, that we were doing the paradigm shift. And today we're doing it again. Imagine a world where all the wastewater is reused. And why not with the membranes of the future?